I am David, your developer on duty, and in this video we will see how to create a query macro in nim. The goal of this project is to create a macro called Neri, and with this macro you can create queries like this. You can just write, for example, select my DB table as my DB, and then provide the columns, and you can even provide some order by columns with ascending or descending. You can also have some renamings for your database table as well as renamings for your columns. So let's get started with an empty project. Nimble init, and we call this project Neri. It will be a library. Initial version is fine. A simple library to create queries in nim. It will be MIT, and that's it. Now let's go into it and change the nimble file, because we also will require Fusion. And let's execute nimble install. And we also want to create a Git repository. And we want to add the relevant files. And you can see there is a test1.nim file where we can write some unit tests. Let's do some test-driven development. So that means we write our test first and then we implement it. And for our test, I want to create a suite first, which I call select. And in this suite, we will have some test. And this will be the easiest query. So it's without columns. And here I can just write let result equals to Neri, our to be defined macro. And then I want to be able to write select and then whatever database table I have, my DB table. And I want to assert that the result ID name equals to my DB table, as well as res columns shall be an empty sequence. Now this will obviously fail, but we can try it out with nimble test, and you can see it fails. So let's go to the implementation in our neri.nim file. Let's remove the generated stuff and let's begin with our implementation. The first thing we should do is to create our data structure to represent our query, or as we like to call it, Neri. So let's create a type, and one of the types we need is ID, and we make it public by appending this asterisk. And ID shall be an object which has a name property, an alias property, a prefix property, and they are all of type string. And what we also need is to create different kinds of queries or Neris. So one for insert, one for select, and so on. So let's create a type called Neri kind, and this Neri kind shall be an enum, and it can for now just be Neri kind select, but here we can later add update and so on. And then we can create our type Neri. Shall be a ref object, and it shall have the field ID of type ID. And now, depending on the kind of it, it can have several fields. In nim, this is called object variant. So let's write case kind, Neri kind. And if it's of kind Neri kind select, then it will have the additional fields columns, which shall be a sequence of ID. Now what's left to do is to create a macro to use it. So we create a macro called Neri, and this macro will get a body of type untyped, and it returns some untyped. And the result will be a new literal of a procedure which we call Neri impl, which takes the body and returns our Neri object. Now we can implement our Neri impl, and our Neri impl will get our body of type nim-node, and it will return a Neri. So we can write result equals to Neri. Now for this to work, we need to import macros. And you can see the error here at newlit went away. So let's see what happens if we execute nimble test. It will obviously still fail, but we can for now see how this body looks like. So we can write echo body.tree represent. And you can see here, this is our tree, which we use in our test. Let's open it again. So we write select mydb table, and internally this is represented as a statement list, as a command, and the first ident is select and the second ident is mydb table. Now to deal with those abstract syntax trees, we can import our fusion matching module, and now we can match our body. So we can write, so the result will be Neri, whatever happens, and now we can write if body matches, and now we can, let's close this up here. Now let's look at this right side here. So it shall match statement list, and that's a sequence or an array of command. And command has two entries. One is the kind, which is an ident, and the other one is table name and also an ident. And if this matches, we want to just echo matches. Let's see what happens if we execute it again. And you can see it's logged matches. So now we have our kind and our table name, and we can create a case statement for the kind. So we can say case kind, and we want the string value from it. And if it's of kind select, then we want to do something. So let's just echo do something, and else we want to just return, or we want to error invalid kind, and we want to return. So let's execute it again, and you can see the do something is locked, so we end up here, which is great. Now let's edit our Neri object. So we write result id equals to id with name is our table name, and of course our result kind is of type select, so we write Neri kind select. And now it should work, but here I need to write table name dot string value because it's a nim node. Let's see again, and our test succeeds. Now let's write our second test. So this one was without columns. So let's write a test with columns, and the syntax shall be kind of like this. So we write a select mydb table colon, and then I want to be able to add column 1 and column 2 and so on. And what I expect is that now I also have columns, so it will not be an empty sequence, but a sequence of ID with name column 1 and one with name column 2. So let's see how our tree representation looks like for the second test. So the first one was this, and the second one will be this. So we have a command, again we have ident, and then we have a statement list, and in the statement list we have all our columns. So we need to match it now here. So now we don't only want to match against the statement list and the command with two idents, but also with a different representation. So we write or, and now we have a statement list of a command, kind is ident, table name is ident, and now we have an additional statement list here. So we write statement list of all statements, and that should also match it. So if we run it again, you can see that the do something echo, which is here, is also executed for the different representation. And now we can loop over all those statements. So we can write for statement of in statements, and if it's of kind ident, then we want to add it to our columns. So we write if statement matches column is ident, then we want to add it to our columns. So we write result columns add id with name equals to column string value. So let's run it, and you can see our test passes. Now let's enhance our functionality and add another test. So these two tests are both passing. So let's see what happens if we add columns with an alias. So we can write, for example, column 1 as my column 1. So if we run it now, it will obviously fail. And you can see here, this is the representation. And we have here in our statement list now an infix. And in this infix, we have ident as, ident column 1, ident my column 1. So we need to match it. So let's head back to our column matching logic. And before we just checked that some column is an ident, which was perfectly fine before, but now it can also be this infix here. So let's add this. So if this one is of kind infix, and this infix will have three idents. So first one is the as infix is ident. The second one is the original column is ident, and the third one is the alias is ident. And now we can edit. So we have name will be column string value, that's fine, and alias will be alias as a string value. Now let's head back to our test and check that this will also be the correct case here. So for column 1, we expect that the alias will be my column 1. Now let's run it, and you can see it passes. Now we also want to have aliases for tables, so let's just copy and paste this test here and call it table with alias. And we want to be able to write something like select my DB table as aliased table. And then obviously the alias shall be aliased table. Now let's run it and see what the structure is. And you can see that we have our command select, and now we have this infix here, which is expected. Now we have to adjust our matching logic. So as you could see, table name is not just an ident, it can also be an infix. So let's just abstract this away and just call this table. And now we have to match table, so we can just write if table matches, and the first one would be an ident. So we just say table name is ident, then we have the table name, and otherwise if table matches, and now this infix, so we just write infix, and here we have again this as infix, as ident, then we have the original table name, so this is with an add, table name is ident, and then we have the alias, this ident, and then we do the same and just write alias as a string value. So let's run it, and you can see there's an error because I probably forgot some, yeah, here must be a bracket, and you can see the test passed. Now we also want to have the possibility to order those fields, so let's just create a new type called order by, which is public, and it's an object which has an ID which identifies the column to be ordered, and it can have some order of type order, and type order we define now. Order shall be an enum, and it can be ascending or descending. And in our select we also have now our order by, which is a sequence of our order by. So let's implement the test for order by. So we just copy some simple test here and just write order by. So what we want to do in the end is we want to have the possibility to write here order by and provide the fields where we want to order with. So we can just write column 3, and by default that should be ascending, but we can also be explicit about that, and we can also write descending. So what we expect is res order by to be a sequence of order by with an ID, with name column 3, and order shall be ascending, and the same with column 4, and for column 5 we have order descending. So let's run this, and now let's check out how the tree representation looks like. So we have our columns again, and now we have here this call of order by with a statement list again, and in our statement list we have again our columns, and it can also be a command here for these explicit orderings, and it is either ascending or descending. We add another if statement matches call. Let's check again how that looks like. So it can be a call with some ID is ident, and also with a sub-statement list, that's this one here. So we write at sub-statement list, and if it matches, then we first have to check that this ID here is order by. So we write if ID as a string value equals to order by, and now we can loop over the statements in the statement list. So we can write for sub-statement in sub-statement list, and now we have to match it, and the easiest one is the ident. So we can just write if sub-statement matches at column is ident, then we can just add it as an order by to a result. So result.order by add, and now we have this order by which has an ID, which is an ID with a name of our column as a string value. And the order shall be ascending per default. But it can also be this command when it's explicit about the ordering. So let's just say if this is a command, let's check again, command, and it has 2 entries. One is the column is ident, and the other one is the ordering is ident. And now we have to specify the order, so let's just write let O equals case order as a string value, and if it's of kind ascending, then we want to return ascending, and of kind descending we want to return descending, and else we want to log the error that this is an invalid order. And we return. And here we just have to edit again. So we have here this order as order. Now let's run it. And you can see the test passed. Now let's clean up our echoes. So this do something we don't need anymore, as well as the tree representation. And if I run the tests, then there's no output, and you can see all those tests, they passed, and we have this nice little query API with which you can construct your queries. I hope I could show you how easy it is to create a query API in Nim. Thanks for watching and stay tuned.